Okay, YouTube, in this video we're going to focus on what we call the horizontal line test in one-to-one functions. And so up until now we've kind of defined functions as being this relation between x and y where every x value is only allowed to go to one y value, or every input goes to one and only one output. And so we would say that anything that satisfies that stipulation is what we call a function of x. Okay, so what we're going to look at in this video is this function of x, f of x equals x squared, our parent quadratic function, which is truly a function here. But what we're going to focus on really is whether or not its inverse is a function. So first thing we're going to do is find its inverse. And so just, like we normally do to find an inverse, we're going to replace this f of x here with a y. And then we're going to switch our x and y around, switch around our domain and range. So we say x equals y squared. And then our last step here would be to take the square root of both sides. So it says we apply the square root property to solve the y squared equals x for y. And we get this y equals plus or minus the square root of x. So the consequence here is this, we could make a table of values, and you'll see this very, very clearly. As a matter of fact, we say x, and then we say, how about y? If we plug in 0 to this function right here, we would get then y equals plus or minus the square root of 0, which is just 0. So that point would be on this inverse graph here, 0, 0, just like 0, 0 was on this original graph of the function here. So now we say, well, what if I plugged in 1? The interesting thing here is then we get y equals plus or minus the square root of 1, which is positive 1 and negative 1. So now 1 goes to both positive 1 and a negative 1. And just like we would, maybe plug in a 4 here. See, 1 goes to 1, 1 goes to negative 1. If we plug in a 4, we'll get 2, but we'll also get negative 2. So very easily here, we can see that this right here would not be a function. And the reason why it would not be a function is just the same reason why we say that the original one, f here, is a function, because it passes the vertical line test. So the interesting thing about inverse functions is that their domains and range switch. So that is to say that for every point x, y that's on the original graph, then on the inverse function here we have the point y comma x. So if that is the case, then what we're really looking for is on the original relationship here, since our x and y values are going to switch on the inverse relationship here, which I can show you that 4 comma 2 and 4 comma negative 2 are on here. Since these have the same y values for two different x values here, they're at the same y value. When you switch this around, it's going to be the same x value goes to two different y values. So essentially this, if this is what the horizontal line test says, if an original function here, say f of x equals x squared, has a horizontal line that anywhere hits this graph 2 or more times, just like the vertical line test would test if this is a function, then if we use a horizontal line test now on this function, then it will tell us whether or not the inverse function will pass the vertical line test. So basically, if I were to put this into English, plain English, since the inverse function doesn't pass a vertical line test on its own, then the function that it was the inverse of doesn't pass the horizontal line test. So if that's all this really says, the horizontal line test is checking to see if the inverse is a function. What we're going to do here with these three examples is we're going to ask this question: which of the following graphs represents functions that have inverse functions? And so again, the horizontal line test is the test whether we have an inverse function, something that is itself one-to-one. So this graph right here, because, bad choice on the color. If I were to draw a horizontal line right here, because this horizontal line hits it twice, when I actually draw the inverse of this function, which will look something like this, it'll fail a vertical line test. So we'd say because it doesn't pass the horizontal line test, we'd say that the inverse is not a function. It exists as a relation, but it is not a function. It's not one-to-one. So looking at this next graph, we'd say, well, I could draw a horizontal line anywhere. And I'm noticing that no matter where I draw a horizontal line, it's only ever going to hit my graph at most one time. So we would say that f inverse here, the inverse, is a function. Because if our inverse function here, or our function here, passes the horizontal line test now, then its inverse is going to pass the vertical line test. And then likewise here, we would say that this, no horizontal line is going to intersect this, more than one time. So we would say that in this case, I'll use shorthand. We say f of, inverse of x exists. We have an inverse function here. Cheers.